Alright guys, today we're going to be talking about compound interest. This term is used a lot with, banking and loans and money. But right here we have the parent function. This is the parent function right here. And basically, what each of these means is the P is the principal, which is, in other words, the starting amount of money that you have. Say, like I start with $1,000 and you go from there. The 1 is to balance things out. The R is the rate. So that could be the tax that you're talking about. The N is the compounding periods, which is different based on the amount of time that you're talking about. For months, it would be 12. For days, it could be 365, and so on and so forth. And then up here, you have the compounding periods multiplied by the time. So the time is like the amount of years that you're talking about over that period of time that that the interest is being compounded. And then N we've already talked about is the compounding periods that you used right here, whether it be months, years, days, or whatever. So yeah, let's get an example problem here. So when you're talking about compound interest, it's really important not to mix things up in the parent equation, or else your answer will end up completely different. So our example problem is going to be, let's say you start with $1,800. Okay, you gotta have the 1 because of the parent function. You have that 1, and then let's say the rate of time, or the rate is going to be 5%. So that's going to be 0.05 because that's 5% in tax. And then let's say the amount of time is in months. So that would be 12 because there are 12 months in a year, obviously. And then up here, it's going to be the N times the T, which is going to be 12 because of the months. And let's say that the amount of time, the years is, let's just say this is over 2 years. Okay? So we have our principal, we have our 1, we have our rate, we have our time. We have our time here again, and then we have the number of years. So this is a sound parent function for compound interest. Now let's put it into a calculator to make sure it checks out. 1,800 plus 0.05 divided by 12 divided by, then we're going to go up here, 12 times 2, and it comes out to 1,988.89, and that is our answer. 0.89, and that is the amount of money. So yeah, just make sure to always have your parent function nailed. Preferably it would be convenient to memorize it, and don't forget to multiply these two. It doesn't really matter which one you multiply first, but it's just important that it's those 2 units. Okay, so let's get another practice problem. Okay, let's say we have $700 in the bank. Okay, you just got your paycheck back. You got $700. You got to have that 1 because it's in the parent function. On the top is the rate. Let's say you're being taxed, or the tax is 7%, so that's 0.07. And let's say this is for every year, or for every day. So 365. A little faded there, but 365. And then up here we obviously have 365 times, here, let me make that a little more clear. 365 times, let's say this is over the course of 3 years. Okay, so that all checks out with our parent function. Let's try it out real quick. 701 plus 7 divided by 365. 365 times 3 years. Okay, our total is going to be $863.55, which is right. So $863.55. So just to clarify, once you start with $700 over a 3-year period, 365 days, gaining interest at 7%, you're going to end up with $863.55 compounded. Okay, this is different from exponential interest, because whenever you're talking about compound interest, the interest is being compounded, except with exponential interest, it's just going at a exponential growth. So there is compound interest. Now let's take some time to talk about half-life. Okay, half-life, we in math problems it's often used with examples of, organisms that have half-life, like isotopes. So this is the parent function. You have the p, the principal, which is basically the starting amount of the amount that you have, like say it'd be like 60 or 50 grams, and then the half is because it's a half-life, and then up here you gotta have 100, or not 100, that's the practice problem I was gonna do, but it's time over the length of the half-life. So this is the way I like to write it: p 1/2 to the power of t divided by L, t being the time and L being the length of the half-life. All right, so let's do a practice problem real quick. So let's talk about the half-life of thorium, which is 25 days, right? Or no, a half-life of thorium is 25 days. That would be going here. So let's say we have 70 grams of it. Okay, that's the principal, 70 grams, and that's obviously going to be 1/2 because of the parent function. And then it's going to be, let's say that we have it for 100 days, okay? So that would be the time, and then the length of the half-life is 25 days. Okay, so here we have the principal, the half. Right here we have the time that we're talking about, which is 100 days. Then we have 25, which is the length of the half-life. So let's check it in our calculator real quick. 70 1/2 25, which is 4.37, and that is correct. 4.75. So this is our answer. Just to clarify, the way I got that answer is through the parent function. The p is the amount that I start with, which is 70 grams. That differs. The 1/2, which is the half-life. The 100 is the time, the period that I'm talking about, and 25 is the length of the half-life. So this is the half-life, this is the length of the half-life, and then I use that example and I got that. So let's do another example real quick. And just to make sure you guys get this and not make a mistake that I made when I first learned this, but a lot of times what I did is I switched the length of the half-life and the time, which totally messed up the problem. You're not going to get the same answer. It's going to be totally screwed up. All right, let's say that we have 45 grams of this half isotope. Okay, that's the principal. We have the half-life. Let's say the time is over the course of 210 days. And the length of the half-life, let's say, is 32. Okay? So let's check this out in our calculator really quick. This is a really calculator-based lesson. 45. 210 divided by 32. And it's going to be 0.476. Which is going to be how much of the half-life we're going to be having. 0.476. It's a really bad 7, but you get the point. So yeah, that is compound interest in half-life. And remember, guys, this is the parent function, and then you guys remember the compound interest function. So yeah, thanks guys. Bye.